harmonics and overtones. When a string or an air column is set into vibrations by some means, the waves are reflected from the ends and stationary waves can be formed. An important condition to form stationary waves depends on the boundary conditions that constrain the possible wavelengths or frequencies of vibration of the system. These are called the natural frequencies of normal modes of oscillations. The minimum of these frequencies is termed the fundamental frequency or the first harmonic. The corresponding mode of oscillations is called as fundamental mode or fundamental tone. The term overtone is used to represent higher frequencies. The first frequency, higher than the fundamental frequency, is called as first overtone. The next frequency, higher, is the second overtone, and so on. The term harmonic is used when the frequency of a particular overtone is an integral multiple of the fundamental frequency. In strings and air columns, the frequencies of overtoners are integral multiples of the fundamental frequencies. Hence, they are termed as harmonics. In this slide, you can see the three diagrams A, B, and C, which are represented as fundamental mode of vibration, first mode of vibration, and second mode of vibration. Figure A is nothing but fundamental mode of vibration, where because of the boundaries, stationary wave is getting formed, and it corresponds to fundamental frequency of vibration. Figure B gives us second mode of vibration, which is higher frequency than the fundamental frequency. So, it is termed as first overtone. Diagram C represents third mode of vibration, which is again higher frequency than the fundamental frequency. So, it is also termed as second overtone. Vibrations produced in a string. The diagram which is shown on this slide, A, B, and C, corresponds to fundamental mode of vibration, first mode of vibration, and second mode of vibration. In the three diagrams, stationary waves are getting formed because of the reflection of the wave. Let us consider the first diagram, A, wherein only one loop is getting formed. The length of the boundaries is considered to be small l. Hence, the distance between two nodes is nothing but lambda by 2. So, for the first loop, length of the loop becomes lambda by 2, which is equal to L. From there, lambda can be written as equal to 2L. The frequency of vibrations of the string can be given by the formula n is equal to V upon lambda. Here, n is the fundamental frequency of vibration, V is the velocity of wave, and lambda is the wavelength of a wave. It can also be written as 1 upon twice L under root of T by m, where velocity of wave can be represented as under root of T by m. Here, T is the tension applied to the string and m is linear density, that is mass per unit length of the given string. In this case, n is called as fundamental frequency of vibration in case of string. Now let us consider the second diagram, B. Here you can see the two loops are getting occurred. So the frequency is termed as first overtone, which is higher than the fundamental frequency. In this case, if lambda 1 is the wavelength of vibrations, the length of one loop becomes lambda 1 upon 2, which is equal to L upon 2. This gives us the equation as lambda 1 is equal to L. Thus, the frequency of vibrations is given as N1 is equal to 1 upon lambda 1 under root T upon M. After substituting the value for lambda 1, we get N1 is equal to 1 upon L under root T by M. Thus, this equation can be represented in terms of fundamental frequency as N1 is equal to 2 times N. So, this is called as first overtone or second harmonic. Let us consider the third figure, that is figure C, wherein you can see 3 loops which are occurring. In this case, if lambda 2 is the wavelength here, then the length of one loop becomes lambda 2 upon 2 is equal to L upon 3, from which we get the relation as lambda 2 is equal to 2L upon 3. In this case, the frequency of vibration is written as N2 is equal to 1 upon lambda 2 under root T upon M. After substituting for lambda 2 as twice L upon 3, N2 becomes N2 is equal to 3 upon lambda 2 and T upon M. After compared, so in this case, the third mode of vibration is called as the corresponding frequency is called as second overtone or third harmonic.